Hello students, welcome back. We went through one example problem on hypothesis testing with Z-distribution. That's probably not enough, so let's do another one. We went through this problem. Now let's go to this. Please stop the playback and read through. Now please recognize that we went through this very problem before. Back in section 1, we went through this problem and came up with this conclusion. So let me copy and paste this. Okay. Now, what's the null hypothesis here? Even though the average birth weight for the babies in the United States, for all babies I mean, is about 3,300 grams, the birth weight for the babies of women living in poverty averages about 2,800 grams with a standard deviation of 500 grams. So this standard deviation came along with a null. Null means none. You didn't do anything. You did nothing. You did not take sample. So this came regardless of the sample. It's the population standard deviation. See the logic here? If that standard deviation came with these 20 randomly selected babies, and their mean birth weight was 3,060, the sample mean, and standard deviation of 500 like that, then that would have been sample standard deviation. But not in this problem. Here, this standard deviation of 500 came along with a null. So it's population standard deviation. Okay, from here, let's go ahead and complete this hypothesis testing. We have two methods here, and we'll do critical value method. All right, here's the setup. We went through that already. And here's a picture, but before just showing you the picture, let me just walk through this procedure. Okay, draw a normal picture, the outline. That's step 1. Outline is step 1. Step 2, center. And that is the null, so 2,800. Lousy writing. And then we want greater than 2,800 as your alternative hypothesis, right? So you want this critical value. And this probability here, the probability exceeding this simply by log, that probability is alpha, and that's 0.05 or 5%. And if you find this x value, then basically we are through, because what we know the sample mean of about 3060. So where does it fall? If you know this critical value, and if it turns out that 3060 is less than that, so that it falls here, then use your brain. Close to null, very close to null, and this is a threshold, so null wins. Now, what if 36 is greater than this x value if it turns out that way? After calculating x value, then basically you are in this situation, falling here, and that's far away from the null. So null lose it, reject null. That's the idea. So the decision-making process is pretty straightforward. Close to null or far away from the null, and how close is close enough, that's the threshold. That's what you're looking for. That's called the critical value, and that's the number you're after. And how do you find this number? Well, this is Z curve. N minus center over SE is Z, and then, this is 5%, the Z-score. You can find out X value. You have done it many times. So that's how you can do it. Okay, let's go back. And here is better picture. 2800, and then we are looking for this value where here 5%. That's the alternative region, and null region is 95%. Now, if we find out this X value, basically we are done. So let's find it out. How do we do that? The Z-score computation, N minus center over SE, which is X minus 2800 over sigma over square root of n, 500 over square root of 20, is equal to the Z-score associated to this 5% here, 95% there. I'll leave that Z-table business to you. By now, everybody must have mastered it. 95% to the left-hand side shading. Look up the Z-score. You'll get 1.64, actually 1.645 approximately speaking, because it'll turn out 1.64 and 1.65 pretty close. So 1.645 is a little bit better approximation, but either 1.64 and 1.65 is going to be acceptable. So solving this thing, flip this to the other side, flipping this 2800 to the other side, or from 2800, add the margin of error, Z times SC. Either way, if you calculate it, you're going to get, I change this Z value a little bit, so it'll change a little bit. Oops, sorry about that. A typo here. Yeah, 2983 points. In any case, 3060 is bigger than that threshold, so it'll fall into the red region, as you can see from the next picture. Make sense? So once you find out the threshold, the critical value, then you can place X bar value in the right place. As you can see, it fell in the HA region, far away from the null. So reject the null and accept the alternative hypothesis. This is the critical value method. This threshold value, this endpoint here, is called the critical value. The critical value. And once you find out that critical value through the Z analysis, N minus center over SE, then placing this X bar and making the conclusion is very, very straightforward. Close to null versus too far away from the null. Geometrically, it's pretty clear. And this method is, I'll say, the preferred method for this course, because traditionally students scored better for this method than the other method.